Namaste. Let's learn Docker today. This course is designed for absolute beginners and all the key concepts are explained with the help of animation for better understanding. Now, before beginning, if you don't have Docker installed on your machine, then you can click on that I button. I have installation videos for Windows, Ubuntu, Mac. So after that, this video is divided into 6 parts. First part explains about what is Docker, why was Docker introduced, all the basic terminologies, basic concepts are explained. This will build a good foundation. Then we jump into Docker commands. So this will be your very first interaction with Docker commands. All the basic commands like Docker ps, Docker run, etc. Then the most important part of the video, that is Docker files. Now you will learn to build your own custom image here, and we'll be using a sample application, a sample to-do application, which is based on Node.js and MySQL. Now here onwards, we'll be using this application and we'll be learning the concepts. Then the fourth part is Docker volumes. Now here you will understand how to persist data. We'll be mostly understanding bind mounts and volume mount. Then comes advanced topics like multi-container setup. We'll learn how to run complex application which has multiple containers, multiple services. And then finally, to ease everything up, we'll learn Docker Compose. So by the end of this course, you'll have a complete working knowledge on Docker and you'll have a good confidence to implement that in your real life projects. So are you excited? Let's get started. Let's understand what is Docker. As a child, you must have played the game of puzzles, wherein you join all the pieces of the puzzle to form an image. The image that is given in the box or in the instruction manual. Now, each and every piece of this puzzle is important to complete the image. Even if a single piece is missing, that image remains incomplete. So, we store all the pieces in a single box, the box that comes with the puzzle. You can take the box anywhere and we can solve the puzzle to form the exactly same image. We can even share the box with our friend, with a cousin, anyone, and she will also be able to form the exact same image. Similarly, in the software world, we need different pieces, that is source code, configuration file, libraries, etc. Docker helps in putting all of these pieces in a single box that is called as container. Now, these container have every single piece of the puzzle, or in our case, artifacts to run the application. Now, this container or these boxes can be run on any other machine, be it your local machine, be it your cloud, or etc. The application will run exactly the same. You'll see the exactly same page. Now you cannot say, but it works on my machine. The problem is solved. There is an open source platform which provides the ability to package and run the application in an isolated environment called as container. Now Docker provides tooling and platform to manage these containers. You can develop your application and its supporting components using containers. These containers, remember, are puzzle box, can be shared with anyone for further testing or further development. Once your development is complete, the same container can be deployed to production as is. This will work exactly in the manner it worked on your local machine. Be the production environment, physical server, on-premise machine, or cloud, it doesn't matter. And consistent delivery. To understand this point, let's take an example of a typical SDLC lifecycle. Developer writes his code on his local machine, tests the same locally, and then he thinks it's ready for the peer review. He sends the container for a peer review to his lead or his peer, anyone senior. Then the lead or the approver verifies the code, runs the container, sees everything is working fine, and then deploys it to development environment. Now in this development environment, he can run multiple checks like sonar scan, Fortify scan, etc. Whatever is there in your CI pipeline. So he runs it and then deploys it to development environment. If everything is running fine, as in if all the automated tests are running good, then the same container is moved to test environment for testers to validate the environment. Once the testers validate it, and if they find any bug, they raise it to the developer. The developer then makes the necessary changes, fixes, etc., and then updates the same base image and then deploys it as a container. This will again go through dev and then again test, and then testers will test again. So everything is validated, verified, and tested properly. All the automated, functional, and the manual tests are complete. Suppose that this updated image is good to go for production. Now this base image should work exactly as it worked on other environments. We don't have to worry if the environments are same or not, because everything we need to run our application is in that image. Do you see how fast it can be? Just update the image whenever you find the bug, and then it can be promoted to higher environments. Another use is responsive deployment and scaling. With containers, just like we saw, the application become highly portable. Like you can scale up or scale down very easily. You just have to bring up containers or bring down containers, scaling up or scaling down. And it will work exactly how we need on any machine. Third use case is running more workloads on the same hardware. Scaling up and scaling down is easy, but you can do the same on the same machine or on the same server. Thereby, you will be efficiently using the resources of that machine. You'll save on the compute cost. Let's understand the Docker architecture. Docker uses a client-server architecture. The different components of the architecture are the Docker client, which is Docker itself, the Docker daemon, which is also called as Docker D, and Docker registries. Docker client is the primary way most of us will interact with Docker, which means when we use Docker commands like Docker run, Docker ps, Docker pull, etc., Docker client sends these commands to the Docker daemon or Docker D to carry them out. Also, Docker Compose is another Docker client. Docker daemon listens to Docker API request from the Docker client to manage Docker objects. Now, what are Docker objects? These are images, containers, networks, volume, etc. Last part, as in the registry. Registry is a place where Docker images are stored. It's like we use Git to store source code. Similarly, Docker images are stored on registries. Now, by default, or Docker uses Docker Hub as the default registry to pull and push images. Means whenever we run Docker pull or Docker run, it fetches the image directly from Docker Hub if you haven't mentioned any other registry. Let's talk very briefly about Docker, some of the Docker objects. So anything that you create in Docker is an object like image, container, network, etc. Images. What is an image? Image is a read-only template which has all the instructions to create a container. Most of the times we will use an image which uses another Docker image as the base image. For example, we will use an Ubuntu base image, and on top of that we will install Apache web server. Then we will install our application and we'll be able to run it. To create our own image, we'll have to write a set of instructions in the Dockerfile and run it. The instruction in the Docker creates a layer so that whenever you're making any changes, only that layer is rebuilt. This really makes Docker very lightweight. A container is a runnable instance of the same image. So you have a template, and based on that template, an instance of an image is created. You can create start, stop image using Docker commands. Well, by default, containers are isolated from other containers and from the host machine as well. Let's see an example. Let me type in Docker run -it ubuntu /bin/bash. Now when we run this command, Docker will check for the Ubuntu image locally, and if it doesn't find it, it will check for the image from the registry, which in our case is Docker Hub, because we're not mentioning any other registry. Then it will download it to create a container from Ubuntu image. Meantime, Docker allocates a read-write file system to the container to create or modify a file in the local system. Docker also creates network interface and connects it to the default network. We'll use host's network connection to talk to the external network. Docker starts the container and executes bin bash because we have mentioned in the command at the start. So if you just run docker run it ubuntu, the container will run and exit because we're not asking it to do anything. When we mention bin bash, that means it will open the terminal and it will wait for a command. So here the flags -i-t, it means the container is running interactively and is attached to the terminal. I stands for interactive and T stands for terminal. Docker is written in Go programming language, and it uses Linux kernel features to provide the Docker functionality. Docker uses namespace technology for the isolation that it creates of the other containers as well as with the host machine. When we run a container, it creates a set of namespaces for that container. These namespaces provide a layer of isolation. Each aspect of the container runs in a different namespace, and also the access is limited. As in, within that namespace itself. So that's it. These were some of the basic terms of the Docker. Now that you know what is Docker, and probably you have also installed Docker, let's understand why Docker was even introduced. So before containerization was even a thing, developers used to face various challenges like inconsistent environments, as in configuration drifts used to occur, then resource intensive VMs, and application development which was quite complex due to manual installation and all of that stuff. Let's go through each of this one by one. First is inconsistent environment. Applications often worked on developers' machine, but it used to break as soon as it was promoted to test or higher environment, acceptance or production. So now the reason used to be difference in the OS version, as in the patch version is different, or there is some configuration that is not present in the higher environment, or even the libraries were not updated. Resource intensive virtual machines. Virtual machines are the go-to solution for making an isolated environment. But virtual machine needs a full-fledged OS for each instance, thus making them bulky, very bulky, and resource heavy, and also it was very slow to start. Complex application deployment. Now, as the deployment mostly included manual steps like manually setting up dependencies or installing required software, setting up the application you're deploying, etc., it was highly error prone. Docker was introduced in the year 2013 and it uses containerization technique. Containerization is lightweight virtualization which packages all the application and related components into a single unit called as container. Now, unlike VMs, container shares the same host kernel. Now, this makes Docker super lightweight, very portable, and easy to replicate. So there, now you know why Docker was born. Okay, now let's get to the fun part. Let's open the terminal. Let's go to Docker Hub. So in this part, we'll be understanding how we are going to pull images from Docker Hub. Meanwhile, let's open the terminal as well. So I'll be using Ubuntu terminal, as in this is I've done with WSL. You can use git bash or the inbuilt command prompt as well. Okay. Let's search for an image called as Nginx. So this is the official image, as you can see. So the direct command for pulling image from Docker Hub is docker pull nginx. But before that, let's see some tags. So what we'll do, we will directly pull the latest tag. There are different versions of the tag. So here you can see this has been created from Debian base image, and there are like different layers that Docker image has. So like environment variable has been set, some copy instructions, some command has been run, then port 80 is exposed, then the final command is run. Okay, so let's pull this image. Let me open this. So as of now, so before this, just make sure if your Docker engine is running. So start your Docker engine. And my Docker is running. You can verify this. So there are no images, there are no containers, and there are no images running. So we'll pull the first image. So what we will do is we will pull this one, nginx latest. The command is very simple, docker pull nginx. So now what you can do is, so if you open Docker documentation, so I'm just telling you so that you'll understand what is the actual command. So here, if you check docker pull, so the actual command is docker image pull, and the command and the image name and the tag. There are even options in between that. These are some of the options. So we will see it one by one. And the alias or the shortcut or the shorthand is docker pull. So even if we run this full command, it will be resulting into the same result. So let's try docker image pull Ubuntu. Logically, it should be colon latest, as in whatever version you want to mention. Like if you want to mention here, let's say if you want to pull stable image, stable pull, you can add this docker pull. So image pull, we are trying the full command, image pull colon stable pull. So here instead of that, we are just taking the latest one. Or you can directly write docker image pull Ubuntu. Or for shortcut or the shorthand, you can do it directly like this, docker pull Ubuntu. So instead of Ubuntu, let us pull Nginx. Nginx. So let's pull the image. Now, meanwhile, what Docker is doing, Docker is downloading the image and then that too layer by layer. Okay. Once all the things, all the components are downloaded, it will say download is complete. So initially what it does is, it will first check in my local if it is there. If it doesn't find the image in a local machine, it will go and search on the Docker hub. Now here, in this command, we have not mentioned any repository. So if you are not mentioning any repository, then it will by default pull it from Docker hub, default repository. Now with this image, let's see if the image is pulled. Docker images. So image is pulled. Okay. Let's create a container with this. Okay. Again, go to Docker hub. Check for the command like docker run will be running. So the long form or the actual command is docker container run and image name, but we will use the shorthand docker run. Okay, and here are some of the options that you'll be using. I will show one or two example here with the options. So if we directly write docker run, now if I write nginx, it will run, but we have not mentioned our host port. Okay, so nginx needs host port to, so because nginx is a web server, so it will need a port to run its application on. So we will be using two options here in this. One is -d, let us search -d, that is detach mode. So if I do not mention -d, it will run in this terminal itself, as in it will not exit, and then we will not be able to use the terminal. Okay, so let's use that -d detach, and then we will use the port number as well, so -p. So this one here, publish a container port to the host. So we will write the port number as well, -p. Now to mention this, we will mention 8080. This is my machine's port, as in this laptop that I'm using. And then 80, this is my containers port. Now if I run it, let us run this. Now you see my terminal is free and this container is run. But if I don't mention detach, then it will take up the terminal and we won't be able to use it. Let us first see if the container is running. To check if the container is running, let's run docker vs and the container is running. So I will explain about this command as well, but let's first see docker run. So let's first check docker run this command first. So here the host port or my machine's port is 8080. So we have hosted nginx on 8080. So let's check if it is running or not. So go to browser, open a new tab, type localhost 8080. So if it was hosted on 80, we would have mentioned like this, and we wouldn't, even if we don't mention 80, then it will by default goes to 80. So we'll mention 8080 because we are hosted on that port. So you can see a default website is hosted. Welcome to Nginx. Now let's clear the screen. Now let's move on to listing the containers. So what is listing the containers? As in, we have already seen the command docker ps, but let's understand the command a little bit in detail. So if we search for docker ps over here, so what it does is lists all the container that are running on the Docker engine currently. So the whole command is docker container ls or docker container list, whatever. But most of the time people use docker ps. Now you might be wondering, if it is docker container ls, why its short form is not docker ls. So I'm not really sure about what docker has thought of, but in Linux mostly ps is used for processes, and a container is a process. So ls, now if I type ls, it will, so I don't have anything over here. So if I write any file, let's say, so if I type ls, all the directories and files in this particular uh, directory will be seen with ls command, will be listed basically. So in case of Docker, so while listing Docker containers, each container is actually kind of a process. So that is why Docker container ps. But the main command is Docker container ls. So basically listing the container is container ls. But when we are running a short hand command, it is like Docker ps. So as in the Docker process. All the containers are a different process. So if we enter Docker ps, we see our container is running. Nginx container is running. It's been up since 4 minutes. Okay. Now let's use one of the options here. Like there are a lot of options for each command. Let's use one of the options, like we used -d and -p in the previous command. Let's use -a here. So what -a does is docker ps -a. So it will show all the containers, the running as well as the exited ones. Like for that, let's download another image. Let's say docker pull ubuntu. Let's directly run it. Docker run ubuntu. You can directly do it. Run ubuntu. It will pull the image and it will also run it. Now, see, we have not mentioned any options over here. So it will just run the container and it will exit, because you're not actually asking it to perform any particular task. So each container has to perform a particular task for it to be running. Now this is done. So same process, it will first try to find the image locally. If it doesn't find the image, and we will go to Docker Hub and it will pull the latest. And remember, we have not mentioned any version here, particular version, so it will download the latest version. Now if we see images, we have two images, the Nginx one and the Ubuntu. But if we see Docker ps, as in if we check if the containers are running, we don't see Ubuntu container here. We'll just see Nginx container. So if we run docker ps -a to see all the containers that were even exited, there you see Ubuntu is there, but it exited. As soon as it was created, it exited. Because we haven't mentioned anything. If you mention like sleep command, or if we run bin bash, it will open the bin bash terminal and it will wait. Let's clear the screen now. Now, if you want to remove the container, if you want to remove this container or stop this container, so what you can do is simple docker stop image name or container ID. Let's try with container ID. It will stop the container. If we see docker ps, you will see nothing. But if you want to start it, docker start, now it's running. See, so simple command. If you want to stop this container, just use the container ID or the image name. You can stop it. It stops. And if you want to start, you just use the start command. But let's say you want to remove the container. So what you can do is docker remove, and then copy the container ID and then try to remove it. Now you're getting error. What it says is the container is running, stop the container before removing or force remove. So here, since our container is already running, so what happens is, although this container has been created from our Nginx image, the image is not totally like independent or unattached to this one. So it creates the container from the image, but when it is running, you cannot remove this container. You can't even delete this container, delete the image. Like if we try to delete Docker RMI Nginx, it will throw an error. You can't remove the image, you can't even remove the container if the container is running. So what we'll do is, we have two options now here. We can directly, we can stop this container and then remove the container, or we can force the container to remove it. So let's try that. Docker rm is the command. So for all the command, you can check it on the website, and then you will have all the options and all the detail about that command. So Docker rm -f and the container ID. Let's copy it. Now it's removed. Now if we check Docker ps, no container is running. Okay. Now let's move on to next one. Now Docker images. I've already shown the commands, but let's understand it a little bit more detail. Now just like when you list container, you write Docker ps, as in Docker ps or Docker container ls. So you're listing container. Now similarly for images, you type Docker images. Since we have like two, let me clear the screen so that it is above. Docker images. So you see there are two images that we downloaded, Nginx and Ubuntu. So this is how listing of images is done. Okay. So using this image, we create a container like we created in the past. So let's try and delete or remove Ubuntu image. Let's try Ubuntu image. So to remove image, the command is RMI, Docker RMI. Mention the, you can mention image ID, you can mention Nginx name. Let's try with Nginx, the name itself. Sorry, it did not copy. Let's remove it. Or we removed Nginx instead of Ubuntu. That's fine. Same thing. Let's see. Docker images and Nginx one is removed. Nginx image is removed. Okay. This is how you can remove. So you can, while removing, you can use the name of the image or the image ID. Anything is fine, not an issue. Now to check what's happening inside the container, we use the command called docker logs. Let's see if we can find this docker logs. Okay, it's right over here, Docker container logs. So let's check. But before that, we deleted our image. So let's download it again. -d -p, the same Nginx image. Let's host it over there only. 8080 Nginx. Now, if you directly do docker run, it will, we have deleted the image, but if we run this command, it will directly download the image as well, and it will run the container as well. So this is a shortcut. So same thing, you will say it did not find it locally, and then it will download the image and it will run as well. So you see, it is downloading layer by layer when it does the same thing. So while it is getting downloaded, let's see any one example. So what happens is, so what is the benefit of layer by layer architecture is, if any changes are done, for example, here we can see there are 18 layers. This is from Debian base image. Now if any changes are done, let's say on the step number 11, so it will just update from step number 11 till 17. If any changes are done like on step number 13, so only 13 and further steps will be updated. So that way it will cache all the previous steps. Thus it makes this Docker faster. Okay, let's see if the image is downloaded. Yes, it is done. Let's see if it is running. Docker ps. Yes, we can see our image is running. To clear screen. Now let's see Docker logs command. So here we have Docker container logs or Docker logs, the shorthand. So if we say Docker logs and if we copy this container ID, we can see what all steps were done to run this command. Okay. So if you face any issue at any point, then the error will be recorded over here. If you monitor, if you want to see if by some reason the image is not, the container is not running, then you will get the error here. Now it says that it has run some worker processes, etc. Then the entry point, as in like we saw it over here, there are different commands here like entry point, docker.entrypoint.sh. So that is also shown here that it is running some part of it, default.sh. So if you face any error, you can try this command. Further, if you want to monitor, you can also run another command called as docker stats. So here it shows you the real-time metrics of CPU and monitor for each container. Now it is showing, we just are running one container, so it is just showing that, and it is not consuming much here. CPU is hardly anything, memory is 0.13%. And memory usage, as in RAM usage, is 10 MB, so not much. Let's exit it. So you can do Control Z or Control X to get out of it. So till then we have covered all the basics as of now, basic command that you'll be using to understand Docker. So let's remove all the images. So remember to clean up. If you are just practicing, then it will help you recover your some of the resources. So let's see what are the images. This images, what are the containers, Docker PS. So this is the container. Let us remove it. Docker RM. I'm directly, without stopping, I'm directly removing it. Now Docker images. Now what you can do, you can remove multiple images as well, like this Docker RMI Nginx Ubuntu. Okay, it is throwing some error for Ubuntu because we have not removed Ubuntu image. So Ubuntu image, Ubuntu container that we created, it exited, but it is still in use. So we'll have to first remove this. So let's delete this first. Docker RM, remove this. Now let's remove the image. Now everything is removed. See, no images and no container. Okay, so for till so everything is removed, our machine is now clean. So to quickly recap what we covered in this lecture, first was why we understood why was Docker even introduced, why how Docker came into existence. After that, we directly checked all the terminal commands. So the commands that we saw was pulling an image from the Docker hub. So for that you just use docker pull and then the image name, whatever the image name is, and then you can pull it. Then we saw how to run the container. For that, the command is docker run and whatever the container name is with the options that you want to provide, detach mode or terminal -t -i. There are different options used. Then we saw how to list a running container. So docker container ps is the command, but shorthand for shorthand we use docker ps to see all the containers. We saw how to start and stop the container, docker start container id or container id, then docker stop container id, container name, whatever you want to use. We also saw some commands wherein we can check if there is any issue with the container. So for that we will see docker logs. It will show step by step execution. For stats, as in if you want to see how much resource your current machine is been Docker is using from your current machine, you use docker stats to check. Okay, so these were the foundation commands, as in very basic commands that will help you get started with the container. In the further lectures, we will deep dive into more Docker commands, and we will be also writing Dockerfile. We will see, so here the layers that we saw on the Docker hub, this is actually a Docker file. So we will see that in further lectures. What is a Docker file? Think of a Docker file as a set of instructions to build the Docker image. It's like kind of a recipe to make the actual food. It contains things like what base image to use, what are the dependencies that the application needs and that has to be installed in the container, and then what files or libraries needs to be copied from local to container, then what command is needed at the startup. So these all instructions are to be written in the Docker file. It's a simple text file, but it is the foundation of creating reproducible and portable containers. Let's see one very basic example. So let's create a Docker file. So Docker file name is simple, Docker file with D capital. We'll create very simple one. So like we saw from, let's see what image to use. So we will just use Ubuntu image. So we will write Ubuntu. Let's put latest. I don't want to mention any other tags. And we will say just, we will try to write just a hello world thing. So we'll just echo. Now to write the commands, we have to mention it in the angle brackets and then double quotes. We'll just write hello world. So this is kind of a very simple Docker file, just two-liner Docker file. If you build it and then run it, it will just print this echo. This will just print hello world. Okay. Now let's see some of the important commands in the Docker file. So we are just using two commands, from and cmd. Let's understand what are the most used, commonly used commands. Let's open Docker hub, and let's open Docker documentation. Here we will just see what are the different commands used in the Dockerfile reference. Now there are some limited instructions, or let's say limited commands that can be used in the Docker file. We will focus on some of the most important ones. Like from is used just to create a base image, just to download the base image, and that base image is downloaded from Docker hub if you don't mention any other repository. Like in our case, we can directly search Ubuntu and then we just directly took the latest version. Now there are different tags that will be useful when you start building for your application depending upon the what is needed in your application, but we directly took the latest one. So Ubuntu latest one. Now after that, there is another important command, that is work directory. Now work directory is just for setting the working directory, or just the directory in which the commands will be executed inside the container. Okay, we will be seeing whatever I am mentioning, we will be seeing most of the commands in the examples. After that, there is copy. Copy will copy the files into the container. So there is a similar command called as add. Now add is similar to copy. It will do everything that copy does, as in it will copy files from source to destination, but it will also auto extract files from the archive. Then there is run command. It will execute command inside the container. After that, cmd, as in command that we saw in the basic example, it specifies the command to run when the container starts. Then there is entry point. Now that specifies default executable command. There is a little bit overlap between command and entry point, but the actual difference, or the main difference is cmd or command can be overwritten with user input. Like when you are building the Docker image, it can be overwritten, but the entry point, it will execute no matter what. Then there is expose. Expose is for exposing any port that you want your application to be running on. And then there's another called env, or environment, that will help you to set environment variable for your application. Then there are different things like label. You can use label to add whatever information you want to add about that image. That's done. Let's start building some Docker files. We'll start with a very basic example. Let's start with the Python file. So what I will do is, this is a very basic, just I'm printing hello world. Okay, so we will first be building it locally to understand how things are working on local, and then we'll try to replicate that in the Docker file so that there is a better understanding about how a Docker file is created. Now here, while creating a Python application, there might be a different there might be different libraries, classes that you are importing. But in our example, we are just using hello world. So we don't have any as such dependency other than just having Python interpreter. So when we run this, we can open the terminal, we can directly run from here. Now let's check we are in the right directory. No, we're not. So let's go to Python. We'll be seeing 3 examples. If you want to run it, what you'll do, you'll just say Python and pay attention, I'm opening it in bash terminal instead of PowerShell. Python and then the file name, it will just print welcome to Docker tutorial Python. Now, what all things we did here is we have Python install latest version, whatever version is needed for your application, you have to install that. That is it. And we are just running one single file, main.py. Okay, so let's create the Docker file, D capital. Let me clear this. So in Docker file, first we have to select the base image. That is, we'll start with from instruction. So for base image, let's go to Docker Hub to see what image suits us best. So let's search here Python. We can take the latest one. Anyways, we don't have much in our code, but you can use different tags. We can try different tag as well. So let's try this tag. Or different versions of Python are there. You can select whichever suits your need. Now, depending on the version, the size might differ. Now, I'm taking a very slim version so that we don't have to install much here, so that it takes less space. And let's paste it. So now the first step is we are just taking the base image as Python :slim bullseye. Let's mention the work directory as well. Work directory. So this is not compulsory for application, but to have a proper organization of your files, you can do that. So let's say main, or let's say application, app file. Then we will copy when we use the copy command. So what we'll do is copy main.py from, this is source, to destination main.py. Since our work directory is already app here, so these all things will be executed inside app. Now here copy from local, as in this is the current directory. We are in this directory. When the Dockerfile will run, it will check for the main.py in this particular directory, and then it will copy to the root directory, as in if we did not mention work directory, it will directly copy to root directory. Now since we have already mentioned the work directory, it will copy to /app main directory. Okay. Then we will directly run the Python command like we did in the local, right? Python main. So we'll do like same thing. The syntax will be like this: open the bracket and then double quotes. We will just say Python, comma, it is in the array or list form, and then we will say main.py. Now let's save it. Now we'll build this image, and then we'll try to run it and see if the container displays the message that we're trying to see. The message is over here. We are trying to get with this message. So to build the command, what we have to do is, so let's see the build command first, so that when you search for it, so here Docker build, and there are different options available. So the main command is like this: Docker build x build blah blah blah, and the aliases are these all things. So we will use Docker build and we will tag it. We'll mention -t. We can also mention -f if you have Docker file in a different path, but here we will directly have it on the same folder as we are running the file. So we will be using this tag. We will tag the image and then we'll build the Docker file. So very simple. Let's do it. So Docker build -t for tag. Let's tag our image Python hello world. And so if you're mentioning file name in if the Docker file is in different directory and you want to mention it specifically, you have to mention -f and then the path to that Docker file. Or else you can directly mention the path as well from here if it is in different folder or directory. But since we have it in the same directory, we'll just mention dot. So now let's enter. It will take some time to build. So let's see if the image is created. Docker images. So we see our image just created now. Now let's run it. Docker run and then the image name. Let's copy it and it should print welcome to Docker tutorial Python. So we just took the base image which had already Python installed, latest version or whatever version you have. You'll have to search for the tag for that. Then we just changed the directory to app and then we copied our main file from source to destination and then we ran the command. So it was all successful and then we were able to execute the file as well. So this was the very simple example where we just had a one-liner and we had no other dependency than to have Python installed and it worked perfectly. Now let's try the same thing for Node.js application. We'll be seeing example for Java Maven as well. Now let's move on to Node application here. Let me clear it and let me change the directory. Okay, so while installing Node.js application, you might have different steps involved. Okay, so like if you want, we can start it from the scratch as well, just to have to understand what all things are needed while installing. So let's delete the dependencies here. We will try to install or we'll try to run this application locally and then we will see how to perform the same steps on with the Docker file or so how to Dockerize that application. So if we click on app.js, so this is just an example that I have taken. Just hello world, we can type like this, hello world from node, like this, hello world node. And our application will be listening on port number 3000 and we'll just print it like that, listening at localhost 3000. But this will not run without the dependencies that it needs. So let's do some steps that are necessary to run the node application. So let's do npm init. Done. Now you can see package.json is there. Now let's install. You don't have to understand these steps, as in I'm just so if you're a DevOps engineer, you'll be already be provided with the steps by the developer what is to be done to set the application locally. If you're a developer for this application, then you already know how to install it locally. I'm just showing so that we know how to replicate the steps on a Docker file. Now let's run the application and see if it is working. Okay, it is listening at 3000. Of course, we are just running that port. Let's see if it runs on our localhost 3000. Okay, so it says hello world node. Now remember what all steps we did. We did npm init, we did npm install, and then we ran node app.js. We did this locally because we wanted these dependencies to be installed. But while creating a container, we can directly copy these files. So the installation part that we'll have to do, but we don't have to do init again because init will just create the package.json that we already have. So let's create a Docker file now. D capital, no extension, Docker file. The same thing we'll first use from the base image as well that we want to use. Let's go to Docker Hub and search for node. We'll go with the official image, and without thinking much, let's go with the latest one itself. Let's just say node latest. Now, what was the next step? Let's mention the work directory as well. And here as well, we'll just have the same thing. Let's say it is app. Now, first what we'll do is we'll copy package.json. So usually package.json has all the dependencies that needs to be installed. In Python, like we have requirements.txt. Similarly, here it is package.json. So let's copy it. Let's copy package, dot JSON, or let's do one thing, package.json and package log.json. Let's install both of this over here. Now we can install all the dependencies mentioned in the package.json. So for that we will be doing run command, and we will just say npm install. So it will install everything that is mentioned in package.json. Now final step, let's copy everything. That is, in our case it's just the app.js, but let's say dot so that you get that flavor as well. So dot from source and dot till in the container. Post that, we will just put the command node like we did over here, node app.js. So we'll do the same thing here. Curly brackets, square brackets. We'll say node. Since it's a list, we will say app.js. Now you can mention label here as well, and then mention whatever label you want to mention. But for now, let's skip it. We'll see this in the official example when we encounter it. It might be in the next video, but for now, let's see it over here. Let's clear it. Same step now. We'll first build the image, and we have the Docker file in the root directory itself. Let's build the image, docker build -t, and let's name it node hello world, and the path to the Docker file, that is current directory, and so dot. Let's run it. So depending upon the file size from where you're installing it, it might take time, or it might happen early. So this is done. Let's see if the image is formed. Docker images, and we have node hello world as well. Let me clear the screen. Docker images. Let's try to run this image. Docker run. Now I can mention -d to run it in detached mode, and then mention -p for the port. But I want to see what message it is printing. Basically, I want to see this message, example app listening, blah blah. So let's remove it for now. We can try that as well. For now, this, and we'll be mapping it with 3000 locally and 3000 port on that as well. Let's on the container as well. Let's copy this node hello world and this enter. Okay, it says it's listening at 3000. Did we close this application? Okay, it is already running. So let me cancel it so that you know it is not already running. Let's try it again. I closed it. We can map it to a different one with no confusion. Is that 3001? Okay, it still says 3000 because this is hard coded. So, but currently application is running on 3001. Let's try that. Localhost 3001, and we can see hello world from node. So application is running. And type Control C to exit it. Now what we can do is let's put -d over here so that it runs in detached mode. Let's change the port again. So you see the terminal is free now when we run it in detached mode. Let's see if application is running. Localhost 3002. Okay, so it's running, not an issue. So what we did was we did the exact steps that we did locally, just that on local we had to init as in initialize npm. as in create the package.json. Then we had to install all the dependencies and then run the command. On Dockerfile, since we already have package.json created, we just first copied package.json and package log.json. So there we are mentioning package star.json, and then we ran npm install to install all the dependencies, and then we did copy everything to uh, the app directory here, and then we just ran node app.js. So similar way. Now this was slightly uh, one step ahead of the Python application, where we did not install anything in the Python. We already had the installation done for Python, and we ran it. Here what we did is we took an image which had Node already installed, but we installed all the dependencies as well. One command extra. Now let's move on to another application, Java Maven application. There we will see how to create a multi-stage run, as a multi-stage Docker file. Okay, let's close it. Close this. Now this is also a simple example that I've taken. Let's change the directory. CD. Okay, so we have this application, and I have to go one step in as well, so that I am in the directory where the POM is, otherwise it will not install. So now let me tell you one thing. So before setting this up, while I was trying to set this up locally, although it is a very simple application, but there were some challenges that I faced. The challenges means I already had JDK versions, different JDK versions in the application for practice that I usually do. And my Maven version was like a one step or one or two versions behind. So I had to install the latest JDK, latest Maven, and then it was working. But I faced a lot of issues wherein it said the JDK version is old, or the version that Maven supports is not installed. So I had to uninstall everything. I had to check the environment variable, lot of things. But in the meanwhile, when I was trying to create the Docker file, it uh, it did not take me much time. As in, the Docker file creation was very simple, since we are directly taking the images from the Docker hub and running it. So it was quite fast than setting it up locally. So this is what we were talking about in the previous lectures, wherein we said there is no dependency on the environment. Like in my app, in my local system, there were different versions of the JDK and Maven. This is very simple example, but in real world, where there are servers or uh, VMs that are hosted on cloud, if you do not use Docker, and if you have multiple environments like dev, UAT, SIT, production, versions might be different if a proper installation is not done every time. So in that case, Docker helps, because you have to just create the Docker image and everything is inbuilt in that Docker image. So that was just to give you a glimpse of what Docker can do. So let's run it, npm clean package. So I'm just trying to create package locally. I already have Maven installed. I already have JDK, whatever the latest version is installed. I'm just running basic hello world program here. Okay, so it is running properly. So to run it locally, we just did mvn clean package. So this is the only command that we need. But we also need Maven latest version. We also need JDK latest version. So what we'll do is, same thing. Let's create Dockerfile with D capital. Say from. So I'm having a latest version of Maven 3.9.6, and I've taken this version. So this is the task that you will be mostly doing it when you're creating a Docker file, checking the exact compatible version with your application. So that is the thing that will take more time. So what we'll do is, since we're building multiple stages here, so let's have a different image for this, and let's name it as build. Now from Maven, as in from this image that already has Maven installed, we will then move ahead with, we'll just mention working directory. Let's do it same here, like let's say app here, like we did it in the previous one. Then let's copy everything from local dot to slash app, and now let's run. our application mvn clean package. Now this thing, what it will do is it will create the this file. If we go here, it will create the jar file. So if we go ls hyphen target, it will create this jar file, the executable. Yeah, maven docker app 1.0 snapshot.jar. So basically this is compiling it. But what we want is we want it to run it. So for local, in local, what you will do is you will directly, let's try to run it locally. If you go over here in target to run like java hyphen jar and the image name, it just says welcome to Docker tutorial Java Maven. So after compiling, we'll be doing the same thing. So what we will do is we are dividing it into two parts. This will be a different stage and this will be a different stage. Now again, to create another stage, we will be needing a different base image. I will be using this one. I've already found out how, if this works or not. Same thing, we'll just say it to choose work directory as app. Then now we don't have to copy everything here. We just want this one from the target, the jar from the target. Okay. So here a little bit of trick here is, while writing copy, we will copy it from stage. From which stage? Build stage. From build stage and the path. Now the path is, we are copying it in app, and then on our local we can see it was created inside the target folder. So we'll mention that target, and the application jar file name is this one. So we'll say this jar file, and let's rename it so that there is no confusion. App.jar. And then finally cmd. Same thing that we did how we did it locally. Java jar, and now we can mention this one, but we have already renamed it. Let's call that then app.jar. Now let's try to run it. So you see there are two different stages. One is the build stage, and then from this build stage we are copying snapshot image as a jar file, and then we are running that. So this way, since different layers are formed here, this way if we did everything in one layer or in one Docker stage, then it will take much more space. Here it will just take lesser space, since we are not keeping the build image. So let's clear the screen, and try to execute this one. Okay, let's first change the directory because we're in the target folder. We should have the Docker file in the same folder. Docker build -t hello maven hello world, maven hello world, and images in the same folder currently. So dot. Now let's see if the image is formed. We see this, so let's run it. Docker run the image maven hello world, and we get the output. Welcome to Docker tutorial Java Maven. Okay, so we are good here. So let's quickly go through what we did today very quickly so that we can see what are the differences over here. So first we saw a very simple file wherein we just had an Ubuntu base image, and then we ran hello world. We did not run it, it was just an example. Then for Python, what we did is we took a basic Python image which had a very slim version of Python installed, and then we copied the main file from source to destination, and then we ran Python main. It was quite simple. Then we understood how we installed the applications, or how do we Dockerize an application which is written in Node.js. So we took the Node.js image, then we copied the package.json and package log.json, and then we installed everything that was mentioned in the package.json. Then we copied everything, and then final command node space app.js. And then finally, the latest one, wherein we saw how a multi-stage Docker file is created. So this is the stage one, this is a different stage. So this stage is called as build. For multi-stage, as in to name the stage, you use as. So this was the build stage wherein the compilation was done and the jar file was created. And this is the execution phase wherein we ran the jar file with Java jar and the jar file. So let's containerize an application. So this is the repository, GitHub repository. Application name is getting started app. So let's first clone it. So I've just created another folder here. Let's cd into that folder. Git clone and then the URL. Okay, if we now see, you can see everything is downloaded. Let's cd into the folder. I'm just clearing the screen. So we can see the things that we need to run this application is already there. Now what we'll do is, we will directly check, we'll directly have this Docker file. Let's create a Docker file. Docker file. So the scenario is like this, that you have joined a new team where the application is already Dockerized. You want to first check if it is running properly on your local. So everything will be already set up. So we will not think much. We'll just copy this. So we can, so initially when you will get into a new team, you will first check what all things are there in the Docker file. So here they are taking base image as node and it's LTS Alpine version. So usually Alpine version are a lightweight version. They do not have many bloats in there, as in only the needed things are there. Then the work directory is the app, and then copy dot to dot, that means copy everything inside the folder here to dot, as in work directory. Here the work directory is app. Then we are running yarn install, and then we will run the node application itself, and we are exposing port number 3000. So this image has already node install in it, so we don't have to install node here. Setting up locally means we will try to run it locally on Docker. We're not running on local system here. We're just running locally on Docker. Okay, so the same steps. So I'll be just following this example here. Everything is written here. So the same thing, Docker build -t. Before that, just make sure if your Docker is running or not. So I've deleted all the containers. I've kept the images as is, and let's run the Docker as well. And before this, let's check if Docker commands are working. Okay, it's working. So make sure the Docker file is in the same directory. So here Docker file is in the same directory. Let's build the image. Docker build -t. Let's name it getting started app, getting started app, and then dot, as in current directory. Docker file is present in current directory. Let's build it. Okay, we're getting some error. So I was getting some authentication error. So I did Docker login and then followed the instructions, and now I'm able to fetch the image. Some authentication problem. Okay, the Docker build is complete. Let's check Docker. Let's pull it up. Docker images. Okay, we have this one image now. While troubleshooting the error, I had to clear the system with Docker system prone, and that's why you see just only one image here now. Let me clear it. Now let's run the application. Okay, so running will be similar that we did in the past. So what we will do is we will do like this: Docker run -d in detached mode, then -p. You can write it like this as well, d and p, and we will expose 3000. So here they have mentioned 127.0.0. We will not mention it because that itself means localhost, and we will anyways be hosting it on localhost. And then we will mention the name, getting started app. Let's run it. So in case you don't know the name, you can always check with Docker images, Docker getting started app. Okay, so now our Docker file, our Docker container is running. Let's check that as well. Docker ps, and our application is running, and it is running on 3000, port number 3000. Let's check that. Localhost 3000, and you can see our application is running. So this is a to-do app. We can type something like Docker file part 1 and Docker file part 2. Part 1 is complete. Now we have part 2. So I was just testing the application. Now this is done. Our image is built successfully. Now let's move on. Let's see if anything else is there. Yes, we can see this application. It is running. We can see our container running as well. Let's move on to update the application. So for updating the application, we'll just update one thing here. Let's close this. We will go to source static JS app.js. Don't worry, I'm just updating the text. So here it says no items yet, add one above. So let's say it like this. You need to add items above. That's it, simple. So this is like if you're a developer, you've made some code changes, this is how you will do it. So after making the code change, what you will do is, so first remain in the same repository, same directory as your Docker file, then rebuild the Docker file, and steps will be same. So you will do Docker build -t, and then let's not change the name of the application, name of the image, so that the same image is built, and then dot. Okay, the build is done. Let's run it now. Let me clear the screen so that it is visible. Docker run -d port 3000 getting started app. Okay, so now our port is already in use. That means we have not deleted our container, previous container. Let's delete that. So if we see our old container is running, let's stop it. Docker stop. Then, okay, I did not copy it. Docker stop, and then Docker remove. Let's remove the container as well. Okay, now nothing should be there. Let's see if anything is there. Okay, some older one is there. Let me remove that as well. Docker rm. Now there should be nothing. Docker ps -a. Okay, nothing is there. Let's build it again. Docker run -d. Let's run it again. And now our text update should be visible. Localhost 3000, and you can see our test is updated. You need to add items above. The original text was like this. If we see it, no items yet, add one above, and our changed one is like this. You need to add items above. Now you must have noticed that the ones that we added, as in the to-do nodes that we added, is missing now. That's because we deleted the container and we are not using any persistent storage as of now. So that's why it's not there. Okay, so this was this was updating the application. Let's see if anything else is there in update the application. We updated it. Okay, this is done. Now let's push this application to Docker Hub. Okay, now before pushing it to Docker Hub, go to Docker Hub, click on repositories, sign in with your user ID, and then create a repository. Here, click on create repository. Let's create getting started app. I will use public. Click on create. Okay, the repository is created. Now to push any image to this repository, to your personal repository, you should follow this syntax, or you should use docker push and then your username and then your application name, whatever your application name is, image name is, and then the tag. Okay, so let's try doing that. And also one more thing, uh, before doing this, you'll be anyways asked to log in to Docker Hub as well. So for that, what we will do is, it will ask for password at one step. So for that, we will create a token. Let's go to account setting, personal access PAT, personal access token. Let's create one. Let's name it getting started app. Expiration date, let me put it like 30 days. Anyways, I'll be deleting it after this video. So here, make sure your access is not read only. Otherwise, you will not be able to push any image. So let's give it read and write. Generate. Now, do not share it with anyone else. Otherwise, they will be able to use your account. So to log in, you have to use like this, and to enter the password, instead of password, we are using personal access token. So we will be using this as a token. So now, where is it? Okay. Now one thing is there, if you check Docker images, our image name is getting started app, but we want it to be named like this. It should be named username and then getting started app, and then whatever is your version number. Let's fix that first. So if we see here, what they have said is, to tag it, we just tag it like this and then we push it here. Okay, so let's tag it first. Docker tag. Let me copy it directly from here. And the version, we will keep it as latest, so we'll not tag it, so we'll not mention it. So of course, I missed one thing. So I have mentioned the repository, but I have not mentioned what we are going to tag. So we are going to tag this image. Let's put it like this. And now if we hit enter, it should be tagged. Let's check Docker images. Okay, now you can see another image, and it is, the tag is latest. Now we have not pushed it yet. We have just tagged it locally on our machine, but it is ready to be pushed. So to push it, what we'll do is Docker push and this name. So let's do it, Docker push. And if you forget the command, no issues. You can go to the repository and check this is already there. Docker push, then copy it exactly. Paste it and then enter. Okay, so now this is uploading it to the repository. Okay, the push access is denied. Repository does not exist. Okay, so first we will have to log in. So we have not authorized it. That's why. So let's authorize it. First we will do like this: Docker login -u for username and my username here. So here, if you do not know your username, you can check it over here. It is written over here, or Docker login -u. Now for password, copy this, right click. You won't be able to see the password here. Enter it. It should say login successful. Okay, it says login succeeded. Now let's do the push command again. Docker push, waiting. Okay, it said started the pushing. Okay, so Docker push is complete. Let's check it on the Docker repository, Docker Hub repository as well. Let me refresh this. And we have a latest image here. Okay, now what we'll do is we will run this image. So now the benefit is anyone with this image and with the command docker pull, and since ours is a public repository, can run this same image, and that person will be able to run the application on their machine. Okay, so what we'll do, we have already checked it on our machine. We will check it on some another instance here. So for that, Docker has something called as Play with Docker. This is a online portal provided by Docker, where for a certain period of time, like for 4 hours, a new instance is created in this site itself, and you can test. You don't have to install Docker on it. So if you want to practice something, you can use this. So let's try that. Let's click on Play with Docker. I wanted to open it over here. Okay, Play with Docker. So initially it might show a different screen. Since I have already logged in, it is directly showing me this start button. In your case, it might show some this image and some drop down, and then select that drop down. So for now, we'll just click on start. Let's create an instance, add new instance. So our instance is up and running. What we'll do is we'll directly run this image. Let's go to tags, and this is the command docker pull. So instead of doing docker pull and then running the image, let's directly run the image, so that it will pull the image and then it will run the image. So I'm just copying the name here, the full name. Go to that web playground, play with Docker. So we'll do docker run. Same thing, -d, -p or -dp, port 3000, colon 3000. Let's paste it. For pasting, you'll have to do shift insert, then enter. So it will say unable to find this image locally, so it will pull it from Docker Hub. Now you can see it is pulling it from the Docker Hub, from my user ID. Okay, this is done. Now, since if you remember, in our Docker file, we have opened or exposed port number 3000. So here as well, we have to open port 3000. So here the thing is, to test this, click on open port and mention the port number here, 3000. Click on OK, and your site will be displayed. It will take a little while depending upon your internet connection. So now you see, this is the text that we added. You need to add items above. So all good. We have uploaded an image and it is running properly. Anything else? Nothing. Okay, so this is done. So let's summarize it. What we did is we took Docker's official example of getting started app. We pulled it using git pull, git clone on local. Then we just checked what is written in the Docker file. We pushed our image to Docker Hub. We even updated the Docker. We have even updated the application and then pushed it to Docker Hub as well. And we checked Docker Playground. You can use this when you're studying or when you're doing some practice. You can use this instance will be available for 4 hours. Let's close this instance for now. Before logging off, delete all your images or containers that are running, because that will take resource. First, let's understand Docker storage at a high level. So when you create a container, Docker uses a union file system to manage the layers. Each layer gets its own writable layer, but this layer is ephemeral, or it's temporary, meaning once the container is deleted, the data inside this layer is lost. That is the reason when we created our to-do application, and when we tried to enter to-dos, it was there, but once we recreated it or we deleted our container, those were gone. So let's try to fix this problem today. So Docker provides 4 storage options: volume mount, bind mount, TMPFS mount, and name pipes. We will be today seeing volume mount and bind mount. So mount means attaching. That is it. So we are attaching file system with container. Volume mount is something where data is stored on the file system of the host, but in order to interact with the data, you must create a volume, and that volume will be attached to the container. So although we don't have direct access to the volume here, but this is the best way, as in Docker manages the volume over here. We just have to create the volume, name the volume, as in remember the name of the volume, and attach that volume to the container. Rest, everything is taken care by the Docker internally. Next is bind mount. Now here in bind mount, what we do is we directly attach or mount our local path, like for example C temp or C DevOps, or in our case let's say D DevOps demo, whatever. You can attach or directly map this folder to any folder file system in the container. So this we will see as an example. This will be useful when you want to do development directly from local to inside the container without building the image, as in you make a change in the file here itself in the local system and then directly refresh it, and the container will be running, and then you will be able to see your changes. Then there is TMPFS mount system, where it stores files directly in the host machine's memory, ensuring the data is not returned to the disk. Now this storage is ephemeral. That means the data is lost when the container is stopped or restarted. Okay, this is similar to the basic option given by the Docker when creating a container. And the last one is name pipes, and this is used to enable communication between Docker host and a container. Now here the common use case is to run a third-party tool inside the container and connect to Docker Engine API using a name pipe. So for us, important thing is to understand volume mount and bind mount, which you will be using mostly, and the container file system that is anyways provided to you by default, and it will be only useful, as in the container, the basic one that is already provided, that is only useful when you are doing some temporary stuff to check. But as soon as you want to store something, you want to persist some data, you'll have to use volume mount or bind mount. We are completed part 3. Let's continue with part 4. Before moving, let's understand that our to-do apps data is stored in a file called todo.db. Now here they have used SQLite database. Of course, it is a relational database, but it stores all the data in a single file called todo.db, and its location is this etc todos.todo.db. So we'll try to mount our local or volume to this path so that our data is stored. So let's create the volume. So this is the command docker volume create. We will name the same only. Before that, let's check if there is any volume existing. Docker volume ls, or you can type list as well, or list. Let me type both. So there are no volumes. Let's create volume. Docker volume create todo db. Okay, our volume is created. Let's check if it is there. Docker volume ls. Okay, we can see our volume is created. Now let's map it. Let's map it to our application so that we can process our data. Now make sure, if like me you're using git bash or Windows, use this command. Otherwise this command will not work. Only difference is here the file system will have to use the escape character here, So we'll use this one. Let's try it. Let me clear the screen. Before that, let's see if our images are present. We'll be using this one, getting started app. So same docker run hyphen detached port 3000. Now to mount, let's type hyphen mount. Then we have to mention type equals to, we will be using here volume. You have to mention source and destination. So for source, we will just say to do db that we created. Then for target, so for target, we will have to mention this path here, etc to dos. Now here, if you remember, our application stores data in todo.db and the path is etc to dos. So this is the path, etc to dos. We have to put one escape character, then etc to dos. That is it, and then the name of our container. Images. Pardon me. So the command is simple. The initial command is save docker run -dp 3000. This is for host and this is for the container. For mount, we will be using volume mount here. So that is why type is volume. In case of bind, we will be replacing this volume with bind. Then source and target. For source, we are using here the volume name todo/db. Then for target, we will be using the path where our database is stored. Okay. And then finally, the image name. Let's run the container. The container is running. Let's see it in our browser. Localhost 3000. Okay, now to check if it is working, let's add some to-dos. File1, Dockerfile 2, then Docker volumes. We have completed Dockerfile 1 to part 2. Docker volumes is pending. So we have made some changes. They should get stored in database. So let's close it and let's see if it really worked. So for that, what we'll do is we will first, let's see the containers first. We will delete this and then again create it, and then we'll again see if data is still there. So docker rm. So we will directly force remove it. If you're not force removing it, you'll have to first stop the container. Docker rm like this, and then -f and then id, enter. Let's confirm docker ps. Let's see if anything is there. Nothing is pending here, and the application should not work. Of course, it should not work. Okay, it will not work. Now let's do it again. Let's run the same command again. Now remember, it should persist because we are giving the same volume and data is getting stored in the volume. Let's hit enter. Let's try again. See, the changes that we made are still there. So good, we can work with this. Anything else that we are supposed to do? Okay, so if you want to inspect, so this is also one command. If you want to see docker volume inspect some details or details about this volume, let's try this. It is in the JSON format. Now it shows mount point over here. Now remember, this is not the mount point of your machine. This is for the Docker VM. So you can see var lib. It is not Windows folder structure or directory. It is Linux systems folder structure. But it gives detail about that. So this is in Docker VM. So you won't be able to access anyways. But we can see other things like when it was created, driver type, options, scope, whatever. So this is one command. And we're done with this thing. Now let's move on and use bind mount. Let me clear this. Now what we will do is we will directly, so this is our, we are already in getting started app folder. So this is our whole application. We will map this or mount this to Docker file system and do the development. So let's do it. So here is a quick example. For volume mount, we use type as volume. For bind mount, we use type as bind. Now for source, we used the volume name todos dash db, and then for target, same the path that we were using, todos etc todos. In case of bind, we will be giving our local path over here, and target will remain the same. Okay, so here is a quick comparison. Now let's try it. Let's directly go to our application. Let's do this one. We are in Windows system, so we'll use this one. Now here, let's try and understand this command first. So first line is same. We are just running the Docker container and mapping the ports 3000. Then we will say -w. -w is for working directory. So if you have seen my Dockerfiles lecture, you already know what is working directory. We'll map it to /app. Now you can see we are using double forward slash. Yeah, because we are using here Git, but in case of Linux or Mac, we can use directly one single slash. Then again, same mount option that we saw in the previous one, volume type, just the bind type is different, as in the type is different. Type is bind here. Source $pwd. Now $pw is present working directory. Let's see what is a present working directory. You can directly see here, it should be this current directory, right? So you can directly say this path as well, but for shortcut of making the command a little bit smaller, we can directly use pwd, present working directory. Then target. Now here we will mention the target as /app. This path we will be directly putting it everything over here. Here we are mapping the present working directory, as in this whole thing, this to app folder. After that, we are running an image that we will be using, node image, to run our application. Then we'll run the same command to run the application, as in yarn install yarn run dev. So if you have done if you have seen previous lectures, we have run this command to run the application. So let's do this. Now this will be very helpful. So once we set this up, we don't have to keep modifying our image to see if our latest application is running. In previous lectures, we saw to update the application, we had to run the image again, as in make the changes, build the image again, and then create the container. In this case, you can directly make any changes in the file here, and then it should work. So let's do this. I can directly copy it, but let's write it one by one so that we remember it. And I would suggest while practicing, do not copy paste. Just try to run the command so that it sticks in your fingers. Docker run -dp 3000. Now remember, I'm not mentioning this because anyways I'm running it on localhost. Now to add more commands, you always put /. That way the command is not executed and you should be able to add more commands. -w for workspace app. Now here the type that we'll have to mention now. Before that, let's mention mount. Type is bind. Then same source and destination. Source, we will be using this $ present working directory. Then target is app. Remember to put this in double quotes and escape it. So since source is Windows, we'll have to put the escape character here. Now let's move on to next line. For that also same, /, enter. Let's use the node image. We will just use the same image. Let me copy it directly. And /. Now we will run the shell, the container, and the command will be yarn install, and then we will run it in dev. So don't worry about these commands, as I suggested earlier as well, that these commands to set up locally will be provided by developers. So as a DevOps engineer, you just need to understand how to run it locally. You don't have to memorize any commands to compile the application. So let's run this. Let's create the container using this. Okay. What did I miss? Oh, for working directories. Oh, so sorry. We have missed the slash here. It should be forward slash. It's run now. So it will try to search the image locally, and then of course it will pull it from Docker Hub. Now we are directly running it and mapping it to a local. So while it is running, what is the error now? Port is already allocated. Okay, so so what we did is we were running already something on port number 3000, as in the previous image. We haven't deleted it or stopped it. Let's first kill it. So if not sure, you can just check like this. You can see this is already running on port number 3000. Let's kill it. Okay, this is gone. Let's try running it again. Okay, it's successful now. Now let's see if it is running here. Now this should not be visible. This is the older one that we are seeing. Let me refresh it. Now since we have created a new one, every data should be gone. All the data should be gone. Refresh it again. Okay, now it's visible. Now if we write something for, okay, so this is there, this is working. If you want to see logs for understanding what is happening inside the Docker container, let me first clear the screen. If we run docker ps, this is our container that is running. To check the logs of what is happening inside the container, you can do like this: docker logs and the container name. So these are the things that happened, and it already. So if you see yarn install happened, yarn was installed, everything, and then here it says our application is listening at port number 3000. Our database it is present over here, etc todos. Now let's do the development part using this bind mark. So we'll make any change here. Let's see what there's, what example. Okay, let's make the change in this file. So go to source js app file. Okay, here we have add item. Add item will just say add, just making any text change so that it is visible. Now make sure to save this file. Now if you were not using Docker storage, it would have been multiple steps like compile the image and then check if your application changes are reflected or not. But here we have just made the change. We have saved the file, and then let's go to browser. Our container is already running. Remember, it is already running. We'll just refresh it. Now see here, it is add item. It should be now just add in the button. Let me refresh it. You can see this is gone. Just add now. Okay, so you can see how amazing the bind mount is for developers. You don't have to build the Docker image and then create a container again, and after that you will see the change. Here you can directly just make the change and see it directly on the browser. So mainly volume mount and bind mount is something that is used to map the volumes. The preferred one is the volume first one, volume mount. You don't have to manage the storage. Everything will be taken care by Docker. You just have to remember the name of your volume and then attach it or mount it to your application. But remember, there other than volume mount and bind mount, there are other volume mount types as well for variable use cases. Now you might be thinking, why to have two different containers? Why not install MySQL in just one container? Like, why can't we do that? But yeah, that's a bad idea. First of all, one container must do one particular task, or it must host one particular service, so that it follows single responsibility principle. Then there might be a case where you want to upscale your front end. So if you have MySQL and your application, both the services running in the same container, upscaling just the front end won't be possible. So that is one reason. Then in production, you might think about using managed database services from cloud, Azure, AWS, or Google. Running multiple processes inside a container adds a lot of complexity. So it's always advised to have separate containers for separate services. Let's create a Docker network, custom network. Now to put a container on a network, there are two ways. Assign the network when starting the container, or connect an already running container to a network. So what we'll do is we'll first create the network, and then we'll add our to-do app or to-do app application service or container to that network. So let's create the network here. So let's open a Visual Studio Code. So Docker create. So we are naming our network as to do app. To check if network is created, just do the same thing ls, and we have our bridge network over here. The step is done. So we'll create a MySQL container now and attach it to our network that we created just now. Now here there are some environment variables as well. So for that you can just go to Docker Hub. Here in Docker Hub, in that image, as in we are using MySQL image, there is a section for environment variables over here. So these are the names that you see here. We'll be using two names, two environment variables from there. So do not get confused as to where this name is coming from. So this environment variable is coming from here. It's defined in this image itself. So we'll be passing password and the database that we are creating, to-dos database. Password is secret, as in literally secret. Of course, this is a development environment, so we are passing it like this. In normal case or in a production environment, you'll not be using this way. We'll be using MySQL image and the version is 8.0. Now you see we have defined network here, the previous on the previous step that we created, and we are providing network alias as MySQL. Now this network alias helps a container in the same network to talk to each other with that name. Now when we will have our application container, that container will be able to communicate with the SQL container by using this name in the DNS entry, MySQL. That's the main purpose. So let's copy it and run it. Okay, now let's check if a container is running. Yes, our SQL container is running. Let's move on to next step now. Now what we'll do is we will exec into the container. Now this I haven't shown in the previous videos. So Docker exec command is used to log in or to enter into a container. Like in a Linux machine, you put username and password and you enter into the machine, or in Windows machine you put username password. Similarly, to get access or to go inside a container, we use Docker exec command. Now let's try doing this. Docker exec -it. Docker, let me clear the screen so that it's visible. Docker exec -it interactive terminal. Now one more shortcut. Now while we'll have to mention what which container we want to exec into. Now instead of copying it, you can just write initials like BFE4. Now till here you're inside a container, as in once I execute the command. Now inside the container, what you want to run? We will run MySQL command. Now this is the MySQL command. This is not the network alias. The MySQL command will provide username as root and password we will directly provide when it asks. So let's enter. It's asking password. Now remember, we have given the password as secret. So I'm just entering secret. Okay, so we are inside the container. Now what we have to do is, let's check if the database that we wanted to create is present. So let's do show bases. So you can see along with other databases, that is default one, we have to-dos database as well. So our to-do database is created. Let's exit from here. Now before creating our application container, we will check if we are able to resolve our network alias MySQL. Now do not get confused between two MySQLs. The command that we ran here, this is the MySQL command. So this is, we are executing inside a container and then we are running MySQL command to get the MySQL prompt here. In the next step, we will be trying to understand if the network alias or the DNS entry that we made in this step here is resolvable or not. So we will create another container. Now this image, Nicola NetShoot, this has dig utility already installed in it. So we'll use this and see if MySQL is getting resolved correctly or not. Otherwise, After creating the application container, we won't be able to talk to both the containers won't be able to talk to each other, and we will be in a problem. So let's try this first. We'll run it. Now that this container is running, let's try running dig MySQL to see if MySQL is getting resolved to an IP. Now, if you see in this section, it has an A name, A entry, as an A record is there with a certain IP address. You might have a different IP address. It's random. So, but good news is we are able to resolve it. So that was the only purpose of this, sorry, Docker ps-a of this particular image or container that we ran. So of course its work is done and it is exited. Now let's move on to next step where we run our application separate container, the actual application that we want to talk to MySQL. So these are the steps. Now the first step is similar, same as we have done in the previous videos. Workspace as in the working directory, app, and then our whole directory. So we are using bind mount here because we want the real-time development scenario wherein we make changes in the any application file and it should be visible. So we are doing this. We are mentioning what network we want to use since we have created this network and we want both the containers to talk to each other. So we are mentioning this network. Now here we are using some more environment variables as well. We are providing host name MySQL. Now this is the network alias that we provided. Now this name is necessary so that it can resolve and talk. We are providing user, password, and then database to-dos. This is the node image that we are going to use, and then this is how we are running the application. So let's copy it and run it. Let's hope everything works fine. Okay, so let's see if it is running. Docker logs -f. I'm just taking initial C26. Okay, so you can see MySQL is connected and it's listening on port number 3000. Now let's go to a browser and try running this application. Localhost 3000. Okay, it's running. Now let's add some entries here. Next video will be about Docker Compose. Let's add this. Now the previous entry was already there because I tried it before. So we have added 2 entries now. Let's go back. Now let's check if our entries that we added in this page, if these are present in our database. So for that we will do docker exec into the SQL machine. Sorry, into the SQL container. It's kind of small machine. So let's do docker exec -it and let's provide this name. Now here it will log into this container and then we will provide our MySQL commands. MySQL -u root -p and logging into to-dos database. Password, you might be remembering the password. So we have logged in. Now just let's run this command. Select star from, what is the table name? To-do -items. There you see, we added 2 entries here, Docker Compose and Docker multi-container app here. And it's visible over here. So that means both the containers are talking properly and we have created a multi-container application. Now I understand this is a one step ahead of all the basics that you have went through. This will take a little bit time for you to settle in. So if you want, rewatch the part wherein you got confused, or of course you can add your doubts in the comment section. So let's see what all things we covered in today's video. Why each container should have a single responsibility, how to run a MySQL container and your app container as in two different containers, how to use Docker networks for communication, how to pass environment variables for database connection, and how Docker DNS resolves another container names. When you're working with applications that rely on multiple services like front-end, back-end, database, or 10 other services, it becomes a real hassle to spin up a new container for each service with those long Docker run commands with n number of parameters. Now this becomes a real hassle. Now to solve this hassle or to solve this problem, we have Docker Compose. Now Docker Compose brings everything into a single file, a single YAML file, and into a single command, like that is Docker Compose up. We'll see. And don't worry if you haven't worked on the YAML files. It is quite simple. It's quite human readable. We'll see a little bit of intro to that as well. Now let me tell you one more thing. Docker Compose is kind of infrastructure as a code. It's not a full-fledged infrastructure as a code like Terraforms or any others like Bicep or something of that sort. But it is good enough to bring up containers, networks, volumes, which are still infrastructure. And since you'll be writing everything into a YAML file, you can do everything that you can do with a code, like version control it, make changes and just run the command. You don't have to do manual things. You don't have to manually bring up the infrastructure. It is quite declarative, it is easy to read, and it is kind of perfect to manage multi-containers, as in multi-container apps. So let's see how it looks on our code. So let's create a file. The name should be compose.yaml. Now this name is kind of important. Like you can of course name it anything, but then you will have to say Docker Compose up hyphen f and then mention the file name. But if we just write it compose.yaml or docker hyphen compose.yaml, then you'll just have to say it Docker Compose up, as in just one single command, easy command. Now make sure that it should be in a root directory like I'm mentioning over here. Okay, so what we'll do is we ran two containers in our previous videos. So in this file, we'll mention those two containers and we'll try to manage it. So before that, if YAML is something new to you, let me explain you a few things, very easy things. Now YAML is mostly indentation based, as in if I say fruits, then fruit will become a top element in our YAML file, then put a colon here, then enter. Now to show nesting in YAML, we use indentation. So indentation is a huge thing in YAML. So let's say like this. Now, so ignore the IntelliSense that is shown. Now, since a fruits is a list, we will give a dash here. In YAML, it is a dash for a list. So let's say apple, orange, then banana, space. Remember, space is everything here. Let's not go too far with grapes. Now for a list, it should be like this. Okay, as in the top element name is there, then each items are mentioned. Like if you are familiar with Python, there as well space indentation plays a huge role. But of course you'll write it like this in Python, whatever the list is, right? So similarly here it becomes in this way. Now this is a list, and for dictionary what you'll do is let's say something like vegetable, not S, and let's call it as a dictionary. Now for this dictionary we can say name caret. Now I am creating a dictionary of dictionary here, like key value pair. Okay, and this is how it is. This is a list and this is a dictionary. Of course you can directly say like this as well, orange, Okay, so this is a dictionary, key value pair. So these are the two important things that you have to remember while working with YAML files. Now let's start writing our compose.yaml file. Now for reference, I will be taking the command that we used in our previous videos. So I'm just copying it and I'll keep it here just so that we know what we are trying to convert. Now since this is a latest version, so we'll directly start with services. Before this, we had to write version as a compulsory key element. As of now, it is deprecated, so we will directly start with services. So in our case, we have two services. So you see, this is a dictionary. We are directly writing here. This dictionary will contain more dictionaries, so we will directly write here two things here. Now we want, remember, I'm putting two spaces here. So we'll write app and then we will write MySQL. So we want two services as in two containers. One is app container and the other one is MySQL container. We'll just be converting all of this into YAML style. So for app, let's continue with that. Remember, inside services, there is app and MySQL. As in, this is the nesting. Double space or tab is the nesting. Now here, let's first mention the image here. Let's write image and node 18. Fine, I'm just writing it is here. Then let's write the command. Now command is this, directly copy paste it. Remember to give space, otherwise YAML will keep shouting that it's a syntax error. Now these two things are done. Let's go to first line. Now we'll have to mention the ports here, port mapping here. So for ports, we can directly write here ports. Now ports is a list. Since we are using Visual Studio Code, it is helping us to directly write everything without thinking. But here, remember, ports is a list, so that's why a dash at the start. So let's mention same thing, 8000, like we did in our previous videos. This is fine, this localhost, ignoring that. The ports is done. Now, after ports, we have this working directory, and then we will be creating a volume here. Working directory, we can directly write like this, working directory, and then the good thing is you can directly say /app, like we did it over here. Now you must be thinking, how do I know all of this, or how do we know all of this? So of course, you'll have to go to Docker documentation and then search for Docker compose commands. Just go here and then you will see all of the commands. What command you want to use. You can see there are a lot of commands. And if you want to check what things we have to write inside the command, we'll have to search for Docker compose keys. Spelling mistake, Docker file reference. So if you go here, we can see top level element, then service level element. So top level element as in name, services, etc. Then service level element as in what all things can be used inside services, like annotation, CPUs, blah blah. Then since there are different things that Docker can create, network, volume, etc. So what all things can be used inside that is also mentioned. All the attributes are mentioned, so you can check that. For now, since this is just a getting started video, we will skip all of that and we'll just focus on things that we want to use for application. So we have mentioned working directory. Now let's mention volume. Now this volume is bind mount. So we will be mentioning it this way. In MySQL, we'll be making a name volume. So that will be a slightly different way. So let's write volumes. And good thing here is, instead of writing like this, as in mentioning the present working directory, we can directly say dot here, dot slash, and then map it with current directory in our container. As in, since we are mentioning working directory as app, we'll mention it like this. So the final thing is just the environment variables. Let's mention that. Enter. Remember, these are all at this level, as in inside app. So remember, take care of the indentation here. Okay, let's quickly copy this. Let's quickly copy this from here. Be sure to check your indentation. Okay, so this is done. Our app command is totally converted into YAMLize or compose style thing. Let's close it, as in this, hide it for now. Now let's work on MySQL part. Now let's do the same thing, copy this command so that you don't have to, we can directly see the comparison. So in short, okay, so first same step, we will first create, or we will first write about image, what image we want. We are using here 8.0, so we will do the same thing. We can just copy paste image. So after image is mentioned, we will create, or we'll write about volumes. So now since we are using name volume here, there's a slightly different way of creating that. As in, here we could directly write in a single line saying -v and then volume name and then where to map it inside the container. But here we'll have to mention it at two places. So first is similar, we'll just write volumes and then this thing, it's already coming in the IntelliSense. Just copy paste this thing here, and also at the service level. So remember, at the service level, as in at the top level, we will be mentioning here volumes, and here we will just mention the same name. Now whoever is familiar here with Kubernetes might find this similar, because we do this in the same manifest file as well. So just mention it like this, and then moving on. After volumes, we now just have environment variables. So we have covered image, name is already done. Network we don't have to specify, it will directly create a network. So that's the magic of Docker Compose. And then we just have these two things. So let's write environment variables. Let's copy that. Make sure the indentation is correct. Okay, let's close this. Now we are done with the Docker Compose file. Let me expand it. This is for the app. This is our app service. This is our MySQL service, and this is the volume that we are attaching it to our MySQL. Okay, now the magic. Now before that, you make sure that you are in the right working directory where the compose is. The compose.yaml is in this directory. Okay, so we will just be doing Docker Compose up, and everything will be up and running with just like that. So Docker Compose up, and of course we'll have to run it in detached mode. So -d, enter, done. Now you see, we did not mention about creating a network. It created on its own, as in Docker Compose for a given application stack creates a network. So like we did in previous videos, where we had to create a network and then we have to give that network name to our MySQL container, so that both are in the same network. We don't have to do any such thing here. So a network is created and both are in the same network. Volume is also created. Now the naming convention is a little bit interesting. Getting started up, it is the name of the folder, current working folder that we are in, and then the names, as in the container names, will be based on whatever we are providing name here, and then -1. So it assumes that we'll be creating, like, I don't know, multiple containers. Okay, this is done. Let's see Docker Compose PS. So let's see if our, the commands are like this: Docker Compose up, then Docker Compose PS. Now by now you're quite familiar with PS commands. So it just lists the containers. Now Docker Compose PS will list all the containers running through Docker Compose. So we see MySQL and Node, and our and our application will run at 3000, port number 3000 on our localhost. So let's see that. Let's see localhost 3000, and our application is running. Now for more commands, it is simple. Like if you want to bring down the application, not delete the whole containers, all the containers, just Docker Compose stop. So it will stop both the containers. Now if we refresh it, it should not work. It's down. Now to bring it up, it is down. Now to bring it up, just say, let me clear the screen. Okay. We'll just say Docker Compose start. Okay, now both the containers are up and running. Now this should work. Okay, this is running. Now to check what is happening inside the containers, you can use docker logs command, as in Docker Compose same logs -f that we saw, as in just the compose. Now you see what is happening in both the containers. For a single container or for each container, you can just mention the container name like this. This is for app, and then for MySQL, like this. What is happening inside MySQL? Okay, so these were all the commands with respect to Docker Compose. So nothing like complicated here. Let me clear the screen. And if you have, so if you're running it on the Windows one, as in with the Docker desktop one, you can see if you go to containers, it creates on the, as in on the dashboard, it has like a folder kind of thing wherein it is called as compose stack here, wherein both the containers are inside the main stack of getting started. The whole name is there, application stack name is there. So very interesting, right? So now let's bring down the application. Very simple, Docker Compose. So for up we did up, and for bringing it down we will put it down. Now this Docker Compose down will delete everything except the volumes created. So you'll see. Now see, it deleted the network and both the containers, but volumes are still running. So how we will check it is Docker volumes ls. Sorry, my mistake, volume ls. So you see our volume is still there. So that we have to remove manually. You can do it in the this step as well, Docker Compose down as well, by giving -volume as a parameter, as an option, sorry, not parameter. So let's delete this Docker volume rm, getting started, and I think we are good. Docker volume ls, all clear. Docker ps -a, let's just confirm it. Nothing is there, everything is brought down. So yeah, that's it, I think. Now Docker Compose makes it easier to share, scale and manage multi-container environments, but mostly people will use it in dev and test. Of course, for production environment, you will not be using Docker Components. There are much better solutions. Of course, you will be looking towards Kubernetes for this kind of huge infrastructure, or where you want a huge number of containers running. That scalability is needed. Congratulations on completing this course. This will help you to build a very strong foundation about containerization. Now, this is just a beginning. We'll next learn Kubernetes, Terraforms. There are a lot of things coming on your way. Now, for this video, if you have any confusion, any questions, any doubt, comment section is open for you. We'll meet in the next video. Till then, keep learning. Bye-bye.